Hello, everyone. My name is Lisa Avery, and I am from the Saskatchewan Science Centre. I am here in my home office, and I have such a treat for you today. It is my absolute pleasure to introduce to you Dr. Edward Gomez, an astrophysicist and educator discovering exoplanets at the Las, I don't know if I'm saying that right, Las Cumbres Observatory in Wales. So we also share a love of Doctor Who, so my office has been a little Whovianed. And we're going to talk about some timey-wimey, wibbly-wobbly things. So thanks so much for joining me, Edward.
Oh, my pleasure, my pleasure.
You're keeping well, I hope.
Yeah,
all
that's
these
right.
Things.
Yeah, going slightly insane. I've got twin 3-year-olds,
Oh, wow.
and so keeping them in the house is an interesting experiment, sociological experiment. But
I'm sure for
it's
all
been
involved,
really,
right?
really fun. Yeah. It's been really fun. It's been really hard work, but it's one of those things. You make the best of a tricky situation, and actually, all of us have really enjoyed the time, even if we get on each other's nerves.
Nice. That's awesome. Okay, well, my first question for you today is an obvious one, but it has to be asked. Who is your favorite doctor and why?
Well, this is actually a really tricky question to answer.
It is,
because
right?
there are so many good ones. There are so many good ones. And actually, I like some of the, in quotes, bad ones too, which people have often maligned. So I have a few. I actually have 4 favorites.
Okay.
My first favorite is Patrick Troughton. And the reason for that is because William Hartnell did an amazing job of being the Doctor, and he was old and infirmed and couldn't really carry on. And so instead of just switching out for an actor that looked like William Hartnell, the production team decided, well, we'll play around with something. We'll have the character regenerate, which is now something that we know and love as being part of Doctor Who. But at the time, it was such a risk. And if Patrick Troughton had been terrible, then it would have failed. We wouldn't be having this conversation.
That's right.
It would have been something that ran for a couple of years in the 60s, and nobody would remember it, and nobody would love it as much as we do today. So that's my first favorite. My second favorite is Christopher Eccleston. And the reason for that, obviously, is because Doctor Who languished in production hell for 16 years after sort of an aborted, 19 years, was it? Well, anyway, for a long time, after the failed Paul McGann TV film, which sort of really failed to really capture the moment and didn't really have the successes that everybody, me included, really hoped for. But Christopher Eccleston was the Doctor and only played for 1 year, and the reasons behind that are controversial, and Christopher Eccleston still is not particularly happy about his departure. But if he'd failed, we wouldn't be having this conversation.
That's right.
And he was an amazing Doctor. I absolutely loved his portrayal of the Doctor. It was so different to all of the others, which had become quite gimmicky. The outfit was very much part of what the Doctor's mercurial temperament. And Christopher Eccleston had this very plain outfit, just a t-shirt and a leather jacket, and that was it. It wasn't really an outfit. So he's my second favorite, and he's got amazing performances. And he was battling with inner demons at the time. And he did the production as well. He had mental health issues again, which I think fed into why his departure has sort of blighted his feelings about Doctor Who. My third favorite is Paul McGann, and Paul McGann is someone that not many people think of as the Doctor, because he was only on TV for the Doctor Who movie that had Eric Roberts as the Master, and was my least favorite Master of all time.
I agree.
But
I agree.
Paul McGann Paul McGann has this whole other life in the Big Finish audio dramas, which is amazing, brilliant work. You really see the character of that Doctor, particularly something that's brought out in the TV movie of him being forgetful because his regeneration was interrupted by being put in cold storage by the coroners. And so he's my third favorite because everyone forgets him, and he's actually a fantastic actor, and the Big Finish audio dramas really bring that Doctor to life. And my fourth favorite has to be Jodie Whittaker.
Yay!
Jodie Whittaker is phenomenal.
She is.
It was a risk having a female Doctor, from the sense that there would have been a huge backlash from trolls. Let's just be as vague as saying trolls. If the writing hadn't worked, if the performance hadn't worked, if the whole production hadn't worked, but it did work, and it worked so amazingly well. And Jodie, I think, does such fantastic, playful things with it. She's still got the arrogance that the Doctor has. She's playful like the Doctor is.
Yeah.
She's caring, and she embodies everything that the Doctor should be. And I'm so happy that she's been so amazing, and that Chris Chibnall has done such a good job of running the show and with her as the Doctor. So those are my four.
Those are amazing choices. I would agree with you, and also I would add 11 is the one I fell in love with for sure the most.
Oh, really?
I do love 11, and I love 11 because he's also so playful and hopeful, but he's so beautifully broken at the same time. And I think Matt Smith does a really good job of that. But I love Jodie. I think she's done a phenomenal job. I love her playfulness and sort of, her arrogance, but also sort of her innocence as well. And it's interesting that the Doctor that has regenerated so many times still has that air about her, right? So yay!
Yeah.
Fun.
It's continuity, but it's still fresh.
Yes.
I love.
Yeah. And her spirit, I really love the companions that she's been working with too, and that idea of the fam, and not just like companions, but like more than that,
Yes.
They've gone beyond the sort of the stereotypical companion, right? So
yeah, that's something that up until that point there'd been really a single companion, except for special circumstances, and there's obviously the two ponds during 11's tenure. And something that Terry Nation, who is one of the people who was who's often called the father of the Daleks, and he's one of the big writers of Doctor Who from time gone by, classic Doctor Who particularly. He always said that his preference was an old man and a young, what he calls assistant, not companion, because in the old days they were called assistants.
Right.
I just find that so creepy.
Yeah.
Terry Nation is a lovely, lovely man by all accounts. I just find that is a creepy relationship, and that's why originally the Doctor and Susan were grandfather and granddaughter,
right?
Because the production team saw that actually that's weird. So.
Well, it is 2020, so it's not a relationship that can be fostered now. I don't think at all, though.
Yeah.
All right, let's talk about the observatory and the global telescope network it is part of.
Yes. So Las Cumbres Observatory is a network of 25 robotic autonomous telescopes all around the world.
Amazing.
So these telescopes are some as large as a double-decker bus, or if you don't have double-decker buses in Canada,
we do. Yeah,
you do.
Like in Victoria, like on the west coast, you do. Yeah.
Okay, great. I've talked about exoplanets and talked about the observatory in all sorts of places, and sometimes people look at me blankly when I say double deckers. Double-decker buses, and the 2-meter telescopes are 1-meter telescopes the size of a largish family car, or largest by European standards, and 40 centimeters, of which we have 10. are the size of, since we're all geeks here, R2D2.
Yes.
And those 40 centimeters are the ones which I use with educational groups all around the world. And so because we have these telescopes that are robotic and autonomous, it doesn't matter where you are, you can use the telescopes. You don't have to go to them. You just need an internet connection and you make a request. And actually, you don't even need to be bothered with whether the weather's good at the sites, because you just say, I want to have an observation of this particular thing, and I need it done within this time frame, within the next week, within these very particular time frames, or even quite vague. And the robotic scheduler will say, which is like a computer algorithm, will say, this telescope is the best one for your observation, and it takes thousands of requests from hundreds of astronomers and thousands of educational users all across the world, and it packs them together and calculates the best schedule continuously. It takes about 10 minutes to run, and it does it for like a 2-week period, and then every 10 minutes it wipes that 2-week period and does it again. Continuously. So it gets the most efficient use of these robotic telescopes. It gets very high availability. So if you need observations done, they'll be done really quickly. And it balances things like, things that you need an observation every 20 minutes for the next 2 weeks, to this thing is really important. It will only happen once. Do it. And it balances all requests like that against each other. So it's fantastic, and it's actually used by around 15,000 educational users, 30% of which are from the developing world, and some of which are from Canada. We have an educational partner based in Ottawa, at a museum over there. So we have all reaches of the globe.
That's amazing. Wow. Yeah, that blows my mind. Okay. All right. I wanted to talk a little bit about transiting and how you discover new exoplanets, because I find it fascinating.
Yeah, so exoplanets are discovered, as you said, by the transit method. There are also I've got a little graphic of what the transit method means. Perfect. I'm going to share my screen, and then you can see this. So this is what the transit method is. So you've got a star, you've got an exoplanet going in front of it, and if we take rapid sequence of pictures of the star. So this is far quicker than the transit would happen.
Right.
So if we take pictures, we can see that the brightness of the star changes with time. So this is quite close, but we'd be zoomed away a huge distance, and we wouldn't be able to see the planet going around. We could just see the brightness of the star dipping with time. And so that is one of the ways that you can detect exoplanets. And this has actually been the most prolific way of detecting exoplanets, largely because of the Kepler satellite, and which was a NASA mission to look for exoplanets, and it was looking for exoplanets and it was monitoring the brightness, and it could very accurately measure the brightness of stars, and it could find out when there was a planet passing in front of them. But there are other methods of detecting exoplanets. There are the radial velocity, so that's the transit method in description. A faint planet passes in front of a bright star, and the star's light dims, and this will find big planets, so ones which block out a lot of the light of the star, because you have a more noticeable dip there in the brightness of the star. There are also microlending events, little blips in the warping of space-time. How very appropriate for Doctor Who fans. So now, I'm not sure if I can draw on this. Maybe I can't. But you can see there are all sorts of really strange shapes on here, things that look like snakes. And if I maybe there you go. So you can see this if you can see my cursor there, you can see this and these strange arc shapes. These are warped galaxies. So these galaxies shouldn't be seen by common sense because they're behind this giant cluster of galaxies. So each one of these fuzzy blobs is a collection of hundreds of billions of stars. And that has a huge amount of mass, and that warps the fabric of the universe.
Amazing.
Which is quite a bizarre concept, but it does. It warps the fabric of the universe. This is something that's been known about for more than 100 years. It was Arthur Eddington who used this method to prove Einstein's theory of general relativity during a solar eclipse just over 100 years ago. And by looking at the position of stars before and after the solar eclipse. So this distortion of space-time doesn't only happen with things like galaxies, which are collections of hundreds of billions of stars. It also happens on a very small scale with single stars. And if you can imagine, you've got this situation, you've got a telescope on Earth, you've got a massive star in between you and a distant star. So we're on the telescope on Earth, and we're sort of looking across the picture there. And when the massive star is directly in between us and a distant star, then this warping of space-time happens again. And actually, you see copies of, or different versions of that distant star. And which is weird in itself, but that's like a small scale effect of that big thing that we were seeing with the wibbly lines. And this is a video of it happening, so that if you suffer from motion sickness, maybe look away now, because the camera pans around a little bit.
Okay.
So there's a distant star, and there's a star which is in between us and the distant star, and I've made it artificially bright. Normally, actually, the star in the middle would be so faint you wouldn't be able to see it. You'd only see the distant one. But I've made it artificially bright in this video. So the one in the middle you wouldn't normally be able to see. And there's the distant star is the fainter one, and now we're panning to where we would normally be on the Earth. So when the distant star, it has the gravitational, when the star that's in between has its gravitational field bends the light from the distant star. Now we can see this effect, but it's not very interesting. Now this star is in motion, so it passes in between us and the distant star. And if it has a planet going around it, we see a warping of space-time that has an extra little blip. So you can watch the brightness of the star change normally, but there's a little blip because it has a planet. So that blows your mind a little bit.
Just a little.
That little blip is what we're looking for. And that's a once in a lifetime occurrence when that intermediate star passes in front of the distant star. And it's the intermediate star that has the planet. And that's the star that we don't actually see. We see the blip happen because of the mass of that star, but we can't actually see the light from that star because it's too faint. So the warping of space-time is stronger than the light that's coming from that star, which all sorts of mind-blowing things there. So that's called microlending, gravitational.
Wow, that is fascinating.
Yeah, so it's a chance alignment which is never seen again. So we look towards the galactic bulge, so that the center of our galaxy, where there's lots and lots of stars, because there's a higher chance of us seeing stars passing in front of bright stars, dim stars with planets passing in front of bright stars. And we actually think that dim stars have more planets than bright stars. So there's a greater chance of you seeing dim ones with planets passing in front. So these events aren't fast. So transits take a couple of hours. These microlending events, because it involves a star passing in front of another star, they can be quite long. They can take days or weeks or even months. So you've got potentially a long time to follow those. And the final one is a wobble, a radial velocity method. So you see a star wobbling. And there doesn't appear to be anything. The planet's too faint for you to see, but you see the star wobbling. It moves from side to side. Oops. And you can see this actually in a number of ways. You can actually take pictures, and you can see the star apparently moving left and right, as it were. or you can see the something about the light changing. So this you can split light up into, like with a prism, when you split light up and you see colors, we can do that, and you can see particular features in the star's light shifting left and right, as it were. And so this one finds massive planets. So those are the three methods that are used to discover exoplanets. Now, normally, let's stop sharing that so you can look at me again. Normally, you have survey telescopes which do the discovery, like the Kepler Space Telescope, and TESS, which is the exoplanets, which is I can't remember what the acronym is, but it's another exoplanet satellite. Or you have ground-based telescopes which have normally they can see a large portion of the sky, and they survey it, so regularly go back to the same bits of the sky. And so the large synoptic survey telescope, which has recently been renamed the Vera Rubin telescope, which is phenomenal, because Vera Rubin was a fantastic leading light in searching for dark matter, this sort of strange thing that occupies a huge percentage of the universe. So she's now been honoured, or rather the telescope has been honoured by being named after such a great person. So the Vera Rubin telescope is going to do this survey, and then observatories like my observatory do the follow-up. So we have, we can, once you've discovered something, you want to then look at it for a long period of time, and then check whether a new thing has been discovered or whether it hasn't, which is something the survey telescopes can't do. So it's an ideal partnership between survey telescopes and observatories like Las Cumbres Observatory, which can stare at part of the sky for either a long period, like several hours for a transit exoplanet, or can go back and look at it, once per day, like with the gravitational microlensing.
Right.
So that's how we find exoplanets.
That's fascinating. How excited are you about the James Webb telescope being launched next year?
Yeah, so James Webb is an infrared telescope.
Right.
So it's complementary. It's a space telescope, so it's going to be. Lots of people have said that it's like the successor to Hubble. It'll look at different type of light to Hubble. It'll look at light that we can't see with our eyes, infrared light. And yeah, it'll be able to see actually these faint exoplanets much better than Las Cumbres Observatory can, because the reason that stars are faint is because their light. Sometimes it's because they're just very far away, and sometimes it's because the peak of where their light comes from is in infrared, and so they put out more light in infrared, like incandescent light bulbs and electric bar heaters. They glow dimly because the majority of the light they put out is in infrared, and so so some stars are that type, and James Webb will be able to see them much better and analyze the light from them much better. So yeah, so that's exciting for exoplanets and all sorts of other science,
right?
Dust and solar system and everything. Yeah,
amazing. Well, I guess speaking of new telescopes and technologies, I was thinking we should talk about if there are any new technologies on the horizon that will make it easier to discover new exoplanets.
So the things that are upcoming that would be great for knowing more about exoplanets, what we call the characterization of exoplanets. There are space missions to look at the atmospheres of exoplanets, and that's looking at the atmosphere of an exoplanet through the atmosphere of Earth is phenomenally difficult. It's imagine that you throw some salt water in a swimming pool, and you're interested in how the salt water behaves. It's like that type of problem. It's really difficult to look at it. You can do clever things with color. So you can use filters. So you can look at green, red, blue light. You can look at a transit in each of those, and you can work. You can see that the transit might be a slightly different width or a slightly different depth in those colors, but that tells you very little about the exact chemical composition of an exoplanet. And the exact chemical composition gives you a good idea of whether it will be habitable in the future and whether it be something that we'd like to visit. So there are a few exoplanets missions which will be launched. Twinkle and Ariel are two, which will particularly looking at exoplanet atmospheres, and they'll be able to do spectroscopy, which is what I mentioned earlier. It's this splitting up of light into different colors, and it actually does it more precisely than just colors. It looks at the very particular colors using wavelength. So when I talk about wavelength, every wave has a wavelength and a frequency, and light has wavelengths, and we commonly call those colors, but those colors are normally a wavelength that has a certain width in wavelength space. But if you imagine you shrink those widths so that you're not just talking about red, green, and blue, but you're talking about the very specific colors. So, like you can imagine the whole Pantone spectrum of colors, even more fine scale than that, and those tell you the fingerprints of what chemical elements are in any substance that is shining. So we're looking at things that are called emission spectra. So elements, if you give them some light, will shine at their favorite frequency, and that's a very useful thing if you want to study what the makeup of something is, particularly out in space, because most things shine light, and that's how we see them. The astronomy is relatively unique as a science. Maybe archaeology is its only comparison, where you have a snapshot. You have the light that's coming from a star. You really can't go to a star. We can go to our sun, and that's it. You can go to other planets in the solar system with robotic probes, but exoplanets, stars outside of our solar system, you have to just rely on the light that's coming from. And in recent years, you can look at something called gravitational waves, but I won't get into those, but that's another way that we can study things that are very, very massive. But the light is all you've got. So astronomers are very crafty scientists, and we extract as much as we can from that light. So having a way to look at the elements that are in things like stars and nebulae and planets, planetary atmospheres, is golden to us. And so that's why we're putting out such a huge effort into analyzing that light. So that would be fantastic. That would allow us to know much, much more about exoplanets, and actually a lot more about how exoplanets are made.
Wow, I never thought light would be so important, right?
yeah, that's right. Yeah,
that's
so
incredible.
it's actually, that's something that people forget. If we want to do an experiment, we have to do it on a computer. It's very, very difficult for us to do an experiment. Some people do things in labs with they're called astrochemists, and to grow things like grains of cosmic dust, and to investigate how dust works and things like that. But it's most astronomers just sit there passively looking at the light that comes from the sky, and light isn't just the light that we see with our eyes. It can be infrared, it can be radio waves, gamma rays, X-rays.
Right. Wow. Very cool. Oh my, we could talk about that all day, I think. Okay, in your opinion, and this I think is probably a very tough question, what is the most exciting exoplanet that you have discovered, or has been discovered?
Unfortunately, I've not discovered any exoplanets myself. I'm hoping to be, well, I'm part of an ongoing investigation into an exoplanet that has rings around it, like Saturn's rings.
Oh, cool.
They're huge, and so that's one of my favorites. But that's an ongoing thing. There are all sorts of exoplanets that are exciting for many different reasons. So some of the very early exoplanet discoveries are amongst my favorites, actually, just for nostalgic reasons.
Right.
So 51 Pegasi B was the very first exoplanet discovered orbiting around a star that's like our sun. There was actually an exoplanet that was discovered before, several exoplanets that were discovered before that, but they were orbiting around neutron stars, which is a star that has gone through its life, a star that was much more massive than the Earth, than the sun. It was certainly much more massive than the Earth, and lived its life much faster than the sun, and eventually exploded and condensed itself down into a star which its remains, all of the elements inside that star turned into neutrons. Very, very weird physics behind that. The essentials of an atom are protons and neutrons, and the protons turned into neutrons due to the extreme pressure of the supernova explosion. But anyway, so those two are amongst my favorite exoplanets, not least because for a star to explode and the planets to survive is quite phenomenal. We don't know what sort of state they're in, but
excuse me.
But that's they still survived. 51 Pegasi B is still, it's still a beautiful thing. It was a hot Jupiter, so we call them hot Jupiters because they're the size of Jupiter, but they were very, very close to the star. The planet's very, very close to the star, so they would have been hot because of the heat from the star. But there are all sorts of really interesting exoplanets. The Tatooine planet, Kepler 16b, is a circumbinary planet, which means that the planet itself orbits around two stars. So it doesn't do it like a loop-de-loop. The two stars are going around each other, and then the planet goes around the two of them like that. So,
wow.
But as we're Doctor Who fans, got to say that planet is, you could call that planet Gallifrey.
You could call that planet Gallifrey. Absolutely.
So it's sort of Saturn size as well. So it's not really one that you could walk on. It's that one's a favorite.
Cool.
There's so many to choose from. The TRAPPIST system. TRAPPIST.
That's why I said it was going to be a hard choice for you.
Yeah.
A hard question to answer. Are there a lot of circumbinary planets?
Now there are, yeah. I actually don't know what the number is, but the TRAPPIST system is fantastic because it has a huge number of exoplanets orbiting around it. It has something, I think the last count was something like 9 exoplanets, 3 of which are in the habitable zone.
Oh wow!
So the habitable zone is an area around a star where, if you have a rocky planet, water could exist as a liquid on the surface.
Right.
So if you're too close to the star, it's going to be a vapor. It's going to have all boiled away and be in the atmosphere. And if you're too far from the star, it's going to be ice.
Right.
And then we think that, so it's called a habitable zone because we think that in order for life to exist on Earth, we need liquid water on the surface. As far as we know, that's one of them. We've got a data point of 1 there. There's
right.
no other planets that have any life on them. Although Mars is a planet that is entirely inhabited by robots, because we've sent so many robots to it.
That's right. Artificial intelligence life.
Yeah, exactly. Yeah. So those are a couple of my favorites.
Those are amazing. I can't wait to go to all of them one day. Is there a planet that has been discovered that has the most bizarre atmosphere you could have ever conceived?
So there was one that was discovered fairly recently that was called, it's got a barcode name, it's called GJ405b, and that has a magenta atmosphere, which is unusual, and it's made me very excited because it for you and I are Doctor Who fans, so I'm going to ask you a question now. Do you remember the planet that the family Slitheen come from?
Yes, but I can never say it. Raxicorphosumbrura.
Oh, very, very good. Raxicoricofallapatorius.
That's the one.
Yeah. So I'm gonna share my screen so I can remind everyone listening what we're talking about. So these creatures, the Slitheen, and they're not. That's not a race. That's a family, which is like a mafia family. Yeah, Raxicoricofallapatorius was their home planet, and the only thing that was said about it was that it had a magenta atmosphere. So I'm really happy now that potentially we have discovered Raxicoricofallapatorius.
That's very cool.
So, yeah.
Although the Slitheen are not my favorites, but
no.
I don't want to meet them, but I.
No, exactly. Yeah, they're by all accounts not very nice and very smelly.
No. Amazing. Oh, okay. So this is kind of what we were just talking about. What other planets have been discovered to date that are most like the worlds that we know in Doctor Who? We've talked about Gallifrey a little bit, and we've talked about the Slitheen planet. Any others you can think of?
There's all sorts. Actually, one I just mentioned, the Trappist system. It actually is. It has planets that are like Scarrow, the home world of the Daleks.
Yes.
So that's quite interesting. Oudsphere as well. Oudsphere is the planet of the Ood.
Yes.
And actually, I have a picture of Oudsphere, so I'm going to show that. There we go. That's Oudsphere. So that's a slightly grainy picture of Oudsphere, but that has, I don't know if you can see up in the top, it has a Saturn-like planet in the same system as Oudsphere. We don't actually know if Oudsphere is one of the moons of that planet or whether it's a planet in its own right. I hope that Oudsphere is actually a moon of that Saturn-like planet, because otherwise it would be incredibly close, too close for comfort probably, and the orbital dynamics of that planetary system would be all over the place. And the reason that I'm saying that is actually a friend of mine is the person that actually I'm working with on this system, this planet which has disks around it, has discovered planets with disks before, and so his very first crazy looking planet discovered had disks. If you imagine Saturn, you would be able to, if you put this planet with his first planetary system, his first planet which had disks on it, whose name I can't remember. If you put that in our night sky in the place of Saturn, you'd be able to see the rings in the night sky without a telescope, which is quite phenomenal. They'd be enormous. So that's quite mind-blowing.
That'd be beautiful to see, though.
Yeah, and to date there are a huge number of exoplanet systems. There's something like, I actually looked this up. There's over 4,000 confirmed exoplanet systems, and there's 3,152 planetary systems, and over 4,000 exoplanets, confirmed exoplanets discovered to date, and 700 of those are multi-planet systems, just like our solar system.
Right.
And so there's plenty of scope for finding ones which are similar to ones in Doctor Who. Actually, the difficulty is finding ones which have been described well enough in Doctor Who so that you can find ones that we know stuff about. Actually, one of my favourite early Doctor Who episodes, the Satan Pit, if you remember that one, where Satan is chained up. The Impossible Planet and the Satan Pit were the two.
Yes.
It was a two-parter.
The orange spacesuit.
Yes, exactly. The orange, which have been found all throughout Doctor Who since, which is fantastic. They describe it as the bitter pill. So Crop Tor is the name of the planet that they're standing on, that's orbiting around a black hole in the story, and it's been spat out by Satan, which is the black hole, and that goes back to one of my original favorites, the planets that are orbiting around a neutron star. These impossible planets. How could they exist after a sun has exploded through a supernova phase, much like Crop Tor? Although Crop Tor is actually too close. That's the problem. That's why it's the impossible planet, because it's too close, not that it's orbiting around a black hole. Yeah.
Cool.
That's another one.
That's fun. Yeah, I feel like this list could go on for a long time. But we only have so many descriptions of so many planets in the world, right? In the Doctor Who world. Do you think there are any emerging technologies that maybe one day we could actually have a TARDIS and like go explore these worlds?
Yeah. So there's an astrophysicist called Ron Mallett who is trying to create a time machine.
Amazing.
And he uses lasers to create what's called circular laser beams, and he's trying to invoke a type of physics called frame dragging, and he says that this will work, but various other physicists have said actually your circular laser beams will need to be bigger than the entire universe, and he's gone, yeah, that might be a problem. But so that there are people thinking about this. People have always been thinking about this, right from H.G. Wells and his very mechanical time machine that was literally turning back the clock with two wheels and clockwork. Maybe I'd love. There are solutions to Einstein's theory of general relativity which allow for closed loops in time, so that you could go back in a closed loop. They're not infinite, you can exit them, but normally there's something which stops you, like the equations need an infinite amount of energy, or there's something which is infinite, they need an infinite amount of space, or you need a tunnel that's infinitely long, or you need a loop that's infinitely long. But there are theoretical solutions that allow that. So you never know. You never know.
Fingers crossed, right? Fingers crossed.
Yeah.
I always say this with my friends: when I get my TARDIS, we're going here. When, not when.
Yeah, that's right. When.
So say we get our TARDIS and we go to another world, what kind of steps do you think humans need to take to be able to actually migrate and survive on another planet?
We need to sort a lot of stuff out because just living with the four people that I love the most, or the three people I love the most for the last 2 months has been a challenge. And so sociologically, you need to really sort out how you cohabit for long periods of time. Even getting to Mars, you're talking about several years. If you've got a one-way trip there, then maybe, but I guess none of them will be 3. And I think if
none of them will be 3, and times 2, right?
Times 2, exactly. So maybe that's it. Maybe we'd be all more tolerant if the kids were 13 instead of 3. But we'd need to have a full-on terraforming thing. You need to send bacteria there to sort of start eating up what the raw materials were and kick off an atmosphere. And so we'd need to do a lot of sociological stuff. There'd be a huge amount of technology that you'd need just to lift vast numbers of people from the surface of the Earth. And we almost certainly start with Mars. I think the Moon would be a great place to start. There's water on the Moon. The Moon's close. You can get to the Moon. You know, people did it in the 60s. Yeah. You know, with a computer that was way less powerful than my Casio watch.
Right.
So I think the Moon would be a great place to start. But it's probably going to be Mars. Mars has got more gravity, and you really need gravity to stop things getting more complicated. Neither of them have atmospheres. So, yeah, I think Mars would be a good place to start. And then from there, mining asteroids to create the raw materials, assembling ships in space. And that is how you would do your large-scale colonization. I think what we'd be talking about is generational ships.
Yeah.
You'd need to have, if you were having a colony of people, you'd have to have people who lived their whole lives and never saw anything but the ship. And so those ships would have to be recreation spaces. They'd have to have gardens on them. You'd have to grow your food. You'd have to have law systems. Everybody would have to be tolerant of everybody else. And something that, you know, people are very intolerant at the moment. There's a lot of people who really need to take responsibility for their own actions. You know, everybody needs to take responsibility for their own actions. And so we need a really enlightened society in order to embark on something like this. We need to not destroy the Earth so that we don't have, so that, you know, we do it because we can rather than we have to.
Yeah.
So we need to tackle climate change sensibly first. We need to not be panicked. We need to do this. And we need to think about future generations. We need to take care of kids and grandchildren, because they're the ones that are going to solve the problems of tomorrow.
Absolutely. Absolutely. Yeah, we have a lot of work to do that way for sure.
Yeah.
I've actually been rewatching Doctor Who lately. I've been watching Battlestar, not the original one, but the reboot in 2008. And that whole concept of where you've got this fleet of civilians and various ships that have different purposes. Like there's a mining ship, and there's this ship, and there's battleships, and how they're all trying to transit through space together in a you know, get along kind of way, and they don't, because it's a whole new learning of how to be in a society, right? So yeah.
There's a fantastic series of books by called, I think it's the Wayfarer series by Becky Chambers. Okay. Really beautiful books. They're beautifully written, and they have so much to love in them, from the description of aliens, the description of the fleet, as it's called, in those books. The first book is more like you'd think of as a space book. It's about, you know, a ship of a cargo ship. But the third book is about the fleet. And you can read them almost in isolation, actually, the three Wayfarer books.
Pun intended. No. Sorry, I couldn't resist.
Yeah.
Cool. That sounds amazing. I will check those out. I'm in the need for a good new book, so that's awesome. Yeah. All right. So, do you think in our lifetime we will discover a habitable planet? Oh my goodness.
That's close enough for us to go to. Yeah. So we already have. So Proxima Centauri is the closest star to us, and that has a habitable planet around it. It's 4 light years away, so it takes light 4 years to get to. So it would take us on a ship a long time. We're not even talking about sending things there yet, sending probes, because the timescale is just too fast. It would take hundreds of years, even if you super accelerated very small ships. There's actually people talking about like tinfoil fleet of ships that you could send out that would broadcast a message, very, very small ones that you could beam out with laser beams from the Earth, and you could just sort of project them. Yeah, that's habitable. It's not ideal. The star is a bit cooler than the Earth, and the star is a bit cooler than the sun, and it is a little more volatile than the sun, so it's not great. But yeah, that could be an option, but people are always looking, and from there, then stars are much further. Space is big. To quote Douglas Adams.
Really big. Space is really big. Yeah, crazy. Well, but that goes back to your point about if we are going to do that, having generational ships, like knowing that there's going to be generations that live on the ship and don't ever actually get to that planet, right?
Yeah.
Because it takes so long. Unless we find a way to be immortal, I guess.
Yeah, or travel faster than light.
Yeah, or travel faster than light. That's right.
Wormhole technology.
Wormhole tech. Yes, that'd be amazing too. Okay, so
John Crichton. It's
Sorry?
all in his head. It's all in John Crichton's head.
Yeah, that's right.
Farscape reference.
I haven't watched Farscape for a long time. Okay, speaking of life on other planets, if we find it, do you think we'll ever find life on other planets, and what do you think that's going to look like, or what would you like it to look like?
So life on other planets is a tricky one. So there are two options. The universe is either filled with life, and we just because of the vastness of space we haven't encountered it yet, or there is no life except on the Earth. And both of those are terrifying in different ways.
Totally.
I think life on other planets will be so different to life on Earth that we may not even recognize it. If it's super evolved, it may be intelligent enough to know that we are life, but it might not as well. It might notice all of the radio waves that we've been broadcasting, and it may encounter some of our probes, but like the Voyager probes, which have left the solar system now. It's the furthest things from the solar system. The New Horizons is catching up on them. There'll be sentient gas clouds, I imagine, that live in gas giants, or strange creatures that live in gas giants, like the Ian M. Banks novel. I think Consider Phlebas, I think, is the one that has these sentient things that live in gas clouds, that live in gas giants. So I think it will be so bizarre that we probably first time won't recognize it.
Cool. I agree. I think it'll just have to be so vastly different than what we know as life. I mean, on Earth, we are incredibly blessed to have the biodiversity that we have. But if you think of that, all the biodiversity that we do have, how would that translate on another planet? Like it's wide open, right? It could be anything. Absolutely anything. And I'm fascinated by that. I think that's amazing. I do hope we find some kind of life. It doesn't have to necessarily be intelligent, but it'd be nice to know we're not alone in the big wide universe. If we are, we are. But yeah.
I know. I would love. I used to be terrified of aliens when I was a kid, and now
really?
actually, I used to be absolutely terrified. War of the Worlds, the War of the Worlds, I should say. The Jeff Wayne, whatever it was, the musical exploration of the H.G. Wells novel used to terrify me. My parents used to play it in the car, and it absolutely terrified me. It was also the same time that a British sci-fi drama called The Tripods was on the TV, which I don't know how well that exported, but it was basically a similar idea, that there were these tripods that in the first series you just see people fleeing from them, and they'd appear over the top of trees and buildings and things like that. It terrified me because I was about 7 or 8 at the time. But now I absolutely love it. I'd love it for aliens to come down and say, "You've made a mess of this place, haven't you? You need to sort yourselves out if you're going to join our galactic council or whatever.
Right.
Yeah.
That's a great idea. They come down to Earth and we get schooled because it's
Yep.
true.
Yeah.
We've
Yep.
got a lot of growing up to do in so many respects, hey?
Yeah. Exactly.
Okay, I have one last question. Of all time and space, all that ever
The big
was
one.
and all that ever will be, where do you want to start? Where would you go?
I'm a huge Jane Austen fan, so I would go to Regency Bath,
Nice.
and just enjoy taking the spa waters in Bath, and walking around in Regency dress, and
Nice.
yeah, and that I think would just be wonderful. I'd obviously have had to have had my shots because
Yeah.
I don't want to die of cholera or
No.
tuberculosis or
That's
anything
right.
like that. Yeah.
No, they don't really talk about immunization on the TARDIS ever, do they? They just...
No, exactly. Yeah. Yeah, Jane
interesting.
Austen's Bath. I would love to go
Ha.
to.
I've always said that I would go back in time and see Queen live.
Oh yeah, yeah,
Because I think that would be amazing.
yeah.
Yeah, I've got a list. I have an actual book of like all the places I'd like to go when I get a TARDIS. When I get a TARDIS.
Yeah, I know.
But that might take us all day to read that book. So well,
Yeah.
thank you so much. This has been an absolute delight.
Oh,
I
my
really
pleasure.
appreciate your time. And yeah, I'm gonna stop the button, and then we can keep talking for a bit. But I'm just gonna say thank you so much.
My pleasure.